All right. Welcome in, everybody. So, more discussion today, largely going over Chapter 2, getting ready for that upcoming test next week. Hopefully, you already have your appointment set up and ready to go. Let's see, where are my notes here? So, one thing I wanted to mention is that I posted in the announcements here. Let's move this over a little bit. I'll move myself over a little bit. Do this. That's much better. Okay, so I posted a new announcement in the Canvas, and it's about the Scantron that you will need in order to take this first exam. Okay, now currently the bookstore is open from 10 to 2. I don't know if they're open on Fridays or not, but they're open from 10 to 2 each day. I know because I went one day and it was after 2, so I had to go back the next day. They have the Scantrons in stock. There are plenty of them. They cost less than 40 cents. So with tax, they're going to be, I forget what it was, like 45 cents or something like that. It was less than 45 cents with tax for the Scantron. You only need to buy one because you're only going to need one Scantron for this course. Okay, you only need one. So you don't, like they sell them as a pack of 6, but for this class, you don't need 6, you need one. So you might as well just spend the 40 cents rather than the like $3 in order to get it. So if you click this, it tells you which one it is. It's the Scantron 825E. That is the one you have to have. The bookstore is full of them. If you're taking the test at a different testing center at a different college, you probably can still get your hands on through that bookstore. If not, they're available, Amazon, stuff like that. They look like this, if you can see this, everyone. So it's kind of long. It has 25 problems on one side. That's what it looks like. You probably have used some of these maybe in high school. They're popular in high school and stuff like that. So they're around, so you can... And the back looks like that, but you don't need the back. So you'll fill out the front, fill out your information. Make sure you put your name on it when you turn it in. If I get one with no name on it, then obviously I'm going to have no idea who it belongs to, right? I'll have no way of knowing what student took that test. So make sure your name is on it, and you do all that. And then you should be good to go. So when you go to take your test, make sure, 1, you have already set up, hopefully by now, your appointments with the testing center. This week's coming to an end, so if you don't have an appointment set up yet, you better do it like immediately, because then you're going to be in a bit of a stressful position next week. So have your appointment set up. 2, get your Scantron. That is the Scantron 825E as specified in the announcements for the course. The bookstore is currently open from 10 to 2, I think at least Monday through Thursday. I don't know if they're open on Friday. I tried to find the information on the website, and honestly, the bookstore's information on the website is not good. It's because the bookstore is not actually run by Ventura College. It's Barnes & Noble. Barnes & Noble, the bookstore, runs most of the college bookstores around the country. So actually, it's a third party. So, we have a different company running the bookstore, so we can't really... they're going to have a different website. So, so 10 to 2 daily. I don't know about Friday. I wouldn't risk it. Try to get it done today. But you want to get your Scantron ahead of time. If you're taking the test at 4 o'clock in the afternoon, well, then you can't go to the bookstore on your way to the test because they will have closed 2 hours early. You see what I'm saying? So make sure you get that Scantron wrapped up. It just doesn't make sense for me to be grading like 5, 6, 7 different types of Scantrons. That does not make any sense at all. So you have to have this Scantron, the 825E. They are in the bookstore. Go get yourself one. Okay? Right. So I think that's pretty straightforward. I can't imagine there's too many questions on that. Just make sure you have the right one, and then you're good to go. Don't try to go take it without that, because then your test won't get graded. So there's that. Then the exam. Let's see. Oh, someone's got some info for us. The bookstore will be closed on Fridays. Hours are 10 to 2. Also closed on campus holidays. Okay, thank you for that information, Fidel. The great information. So it's kind of what I suspected. It sounds like the bookstore is closed on Fridays, and they are, of course, closed on the 4th of July. because the whole campus is closed on the 4th of July. So those are times where you will not be able to get them. So you could stop by the college and pick it up today if you need to. Otherwise, plan for next week about getting your Scantron ahead of time. I don't know if they have these things at like Staples or Office Max or something like that. You could check it out. But the bookstore is real easy. You just go in, you buy one. It's like 40 cents, and you're good to go. The type of Scantron that you need, so it's 825E, this long green one. There's 25 problems on the front. It's 825E. And so someone's asking me again what was the type that was needed. So I'm just reiterating. That's why I'm repeating myself here. So and also it's in the announcements for the class. So if you click announcements for your class in Canvas at the top of the page, click announcements. I also specified which one it is. So so you can get that information. Okay, so please get that taken care of. Right. And if there is some weird circumstance where I end up grading one that's not the right kind, there will be a heavy penalty for that. So don't do that to yourself, right? Just get the right Scantron, make sure it's taken care of, and then you can get full credit. You're working hard in this class. You want to make sure you get the A that you know how to get. You don't want to mess up your grade because you don't have the Scantron or something like that. Okay, with that said, if there's no other questions, we're jumping into Chapter 2. Here, which has a lot of stuff. Now, a lot of this stuff many of you have seen before, things like linear functions and finding slopes of lines and stuff like that. Most of you have probably seen this at one point, so hopefully you'll pick it up pretty quickly, but it is a lot of material. Make sure you're watching the videos that are inside of each section. Right, like for circles, that stuff's kind of confusing, but I have a totally worked out problem here where you just kind of follow along with what I'm doing, and it sums up a lot of the things that are like I think it's only one problem that I work through in here, but sometimes there's one problem that covers like everything in the whole section, like the fact that for the formula of a circle, you can figure out where the center is and what the radius is and how to use completing the square in order to put it in the right form. Like this problem encompasses all that stuff. Okay, so make sure you're watching those videos to take care of that, and then and then we're working through stuff. So we had a couple things. Let's see. Today's the 30th. So tomorrow you have two things due on the 30th. You've got the Chapter 1 quiz and then the Testing Center quiz. So just make sure you don't forget to take those because I think people probably be okay with those. So just make sure you take them. If you forget to take something, then obviously you get a 0. You don't want a 0, right? A 0 hurts your grade way more than even like a 50% does. So make sure you don't forget to take those quizzes. Make sure you get in there and do that. And then we'll be moving ahead. We'll cover Chapter 2 today. And then Chapter 3, you're somewhat going to have to work through on your own because we don't have any class. You're actually taking the test next week. So make sure you're watching the videos here. Make sure that you're watching the videos associated to the problems in the homework. And make sure that you're working through the study guide, the practice test, basically. So I know it's a lot. We move so fast in the summer. It's just it's just ridiculous how fast we move, but we have to in order to finish in 6 weeks. Okay, with that said, so looking at the homework, we have a few different things that we're covering. Let's go back here, go to Chapter 2. So we're looking at lines and graphs of the coordinate system. So I think I covered pretty well slope. So slope is, most people kind of remember that slope formula from algebra, y2 minus y1 over x2 minus x1. It's how you find out it's how you figure out the slope for something. So remember, slope is how steep your line is, right? Is it sort of more flat or is it really steep? What's going on with your slope? The slope can also be interpreted as a rate of change. Right, so if we look at if your bank account is represented by a line, then the slope of that line tells us how your money is changing over time. Right? Are you increasing in money? Are you decreasing in money? Are you making $4 a day? What's happening? The slope basically encompasses that information. So I'm going to do kind of one of those problems like I talked about a minute ago, where by doing one problem, it's going to cover like 3 or 4 different topics all at the same time and hopefully help you get the hang of that. So the problem we're going to do, will take the following form. It's going to be find, oops, let's scroll up here. Find the equation of the line passing through 2 points, 2, 1, and let's do -1, 5. Yeah, let's do that. And it looks like we're going over. Let's try this. Okay, so find the equation of the line. Oops, I can't see it if I do that. Okay, let's do like there. So find the equation of the line passing through 2 points, 2, 1, and -1, 5. So ultimately what we're trying to do when we find the equation of the line, that means we're trying to get something in that form y equals mx plus b. That is that, like, a lot of times people remember that, even if they don't really remember what it means, they remember, oh yeah, there was some y equals mx plus b thing, right? So that is our general form for the equation of a line. We call it slope-intercept form. And the reason we do that is this m tells you your slope, and this b tells you your intercept. So it makes sense we call it slope-intercept form. It is the most commonly used form of a line. It's generally the default. It's the one, if you're not sure what form your line should be in, put it in y equals mx plus b form. That's usually the safe bet. So we have to figure out which line. There's an infinite number of lines out there, right? Well, which is the one that passes through these 2 points? We say that in mathematics that 2 points determine a line. What that means is if you specify 2 distinct points, there is only one line that goes through those 2 points. There's exactly one that goes through those 2 points. And we need to find it, right? And there's many reasons why you would try to do this. Maybe you have 2 points of data for your company. You know that in March, you sold 5 million units, and in May, you sold 12 million units. And you want to see what kind of line goes through those 2 points so that you can make predictions about what's going to happen in June or something like that, right? So it's important that we sit down and try to figure out the equation of this line. Well, our final line is going to have the x and the y in it. That's going to stay in there. But what we have to do is figure out this value for m, and we have to figure out this value for b. That's when we'll be done, is when we figured out the m and the b and we stick them in here, then we're good to go. So generally, you're always going to figure out the slope first. Okay, that's the first thing you're going to do. So let's figure that out. We've got the slope, which is oftentimes signified with an m, equals, well, in general, this is given by y2 minus y1 over x2 minus x1. Okay, so that's our formula. So let's remind ourselves what this means. Well, this means that y2 minus y1, that's the vertical change. x2 minus x1, that's the horizontal change. So what the slope is doing is it's taking the ratio of the vertical change to the horizontal change. In other words, if you move forward 1 foot, how much elevation gain do you have over that 1 foot? If by moving forward 1 foot you raise an elevation of 1 inch, then you have a relatively small slope. If by moving forward 1 foot you go up 10 inches, well, then that's a much steeper slope, right? That's, if you could imagine, if you're going on a hike, right? You say, okay, well, after the first mile, how much elevation will we have gained? Oh, not much, like 100 feet. Okay, that's a pretty mellow hike. If you say, okay, after the first mile, how much elevation have we gained? And they say, oh, about 2,000 feet. That's a much more strenuous hike, right? Because the ratio of the vertical change to the horizontal change is much greater. So there's our formula, y2 minus y1 over x2 minus x1. And what is this x1 and y2? What do all these mean? Well, we have our first point, and we just call the x value from that one x1 and the y value from that one y1. And then we have a second point, and we'll call the x value x2 and the y value y2. So you just label them x1 and y2. In fact, you could switch the 2 points if you want. You could make this one your first point and this one your second point. That would totally work just as well. The trick is, what you can't do is mix them up. You can't use this -1 as your x1 and then use this +1 as your y1, because then you're mixing up which point is point 1 and which one is point 2. So as long as you're consistent and you pick one to be point 1 and you pick the other one to be point 2, then you're good to go. Oh, let's see. It's blurry. Oh, okay. So there's a good point being brought up. There's a chat message that was sent to me. So someone is saying that that it's blurry. So sometimes what happens on these live streams is if someone has a poor connection, it downgrades the stream. Because I'm actually watching the stream right now. I open a window in YouTube and watch it to make sure everything's good, and it's completely clear on my screen. So sometimes what happens is, like, most of the class will be seeing it perfectly fine, but 1 or 2 students are getting it blurry, and it's usually because you're on a bad internet connection. So what I would recommend, if you do that, sometimes if you just refresh the page where you're watching the YouTube stream, it'll come back. It kind of resets the page to a higher if your internet connection got better, then it resets it to a higher level, and you should be able to see it, because I'm watching it right now and it's definitely like clear on my screen. But that's a great question. I'm glad you brought that up. Okay, so if I stick these in here, I'm just going to call, let's call this one y2, point 2, and we'll call this one over here point 1. So that means that our y2 is 2, so we go 2 minus -1 over 1 minus 5. So let's see, 2 minus -1, let's remember that's 3, and then 1 minus 5 is -4. So that means the slope of this line is 3 over -4. So 3 over -4. So what that means is this is a negative slope, right? A positive divided by a negative is a negative slope. That means our line should be decreasing. It's going down. If you think about it in terms of your rates of change, well, if your rate of change is negative, what does that mean? That means that your quantity is decreasing. If your bank account has a negative rate of change, that means it's going down over time, right? You're losing money. Negative money means it's going away from you. So our slope is 3/4. We could also, normally we would then write this as maybe -3/4. Okay. But in any case, we've figured out what the slope of the line is. Why is it? That's weird. It rendered it wrong. Oops, because I did this. I put the wrong thing in there. That's why. There we go. Okay, so our slope is -3/4. If you wanted, the negative could go on top. It could be -3 over +4. That's fine as well. That definitely works. Let's look at what that means in Desmos. So we have what? 2, 1, and -1, 5. Okay, so I'm in Desmos. Open the graphing calculator. We've got the points 2, 1, and -1, 5. Were those the 2 points? Yeah. Okay, so that makes sense. If we look at the line that would go through these 2 points, that's a decreasing line. It's your y values are getting smaller over time, right? So let's just double check that our slope is right. This means that if I go up 3, then I should go back 4. Okay. So let's see if that works. So if we interpret this slope of -3/4, that means that if we start here and that, let's see, so -3, that means if we go down we go down 3, 1, 2, 3, and forward 4, 1, 2, 3, 4. Oops, do I have a mistake here? It looks like I do. So I caught a mistake. Oh, right. No, 2 minus negative 1 and 1 minus. Oh. Yep, I do have a mistake. This is trying to do too many things at once. These should be switched. So this should actually be like the following. Oh, here we go. Negative 1 comma 5. Oh, here and rise over. Nope, so I did mess it up. I have this backwards. It's trying to do too much. This is okay, sorry about that. This is what it should look like. I had the X's and Y's in the wrong spot because I'm trying to use technology at the same time. I don't know. Teaching online, there's like extra things to keep track of, and I just got myself mixed up for a second. So your Y's go on top. I accidentally put the X values on top. So that's why this didn't work. But notice how I caught it because I double-checked my work. I double-checked it by looking at the graph, and I went, wait a minute, my numbers aren't coming out right, and I caught my mistake. That's one of the fundamental things about math that people don't understand. You should be checking your work all the time and going, wait a minute, something didn't happen right, and then you can go back and you can fix it, okay? Okay, so if we look here, so our Y values are 1 and 5, so 1 minus 5, and then our X values are 2 and negative 1, so 2 minus negative 1 gives us 3, and sure enough, we have a slope of negative 4 over 3, so if I'm right here, I go down 4, 1, 2, 3, 4, over 3, 1, 2, 3, yep, that puts me right on the other point, so that is the correct slope. Slope can be thought of as rise over run, right? So we know that the slope of our line is negative 4/3. So going back here, we now know that this y equals mx plus b piece should have an m of negative 4/3. Right? So we now know it's y equals negative 4/3 x plus b. But now we just have to figure out what the b value is. Okay, we have to figure out this b value. So we're almost there. Once we figure out b, we're done. So what you do is you just pick one of these 2 points up here, whichever one you want. Most people are probably going to pick 2 and 1 because it has less negative values. It doesn't really matter. They'll both work. And you're going to take this x value and plug it in for x. You're going to take this y value, plug it in for y, and then you can go through and solve for b. So let's do that. So this is going to become, so our y value is 1. 1 equals negative 4/3. Now our x value is now a 2, and then we have plus b. Okay, so see what I did here? I took this equation, I plugged in 2 for x, 1 for y. So negative 4/3 times 2, you can think of this as negative 4/3 times 2 over 1. So that becomes 1 equals negative fraction 8/3 plus b. Okay, now we're going to add 8/3 to both sides. But if we think about it, how are we going to add 1 to 8/3? Well, 1 is really 3/3, right? So we can think of this as the fraction 3/3 equals negative 8/3 plus b. So 3/3 is equal to 8. Oops, I'm missing a negative sign. Eight-thirds is equal to negative 8/3 plus b. So when we add 3/3 to 8/3, we're going to get 11/3. So it looks like our b is 11/3. So putting that all together with the whole problem, then we know what b is, so we should plug it in here. So that means it looks like our problem, our final equation, is that y is equal to, what was it, negative 4/3 x plus 11/3. That should be our final equation. So let's come over here and double check it in Desmos. So y equals negative 4/3 x plus 11/3. Sure enough, notice our line goes right through those 2 points. Therefore, that is the equation of the line that goes through those 2 points. So that's how you do that. So in that problem, we had to calculate slope, which is one thing that you'll have to do for a number of problems, is calculate slope, a number of the homework problems. And then we found the equation of the line that goes through 2 points. If you're good with that, you should get most of what's going on. One thing that you, just to be sure that you understand, whenever we graph something, what we're really doing is just looking at a representation, a visual representation of the solutions for that equation. So in other words, the x and the y values, if we plug them into our equation, they should make things work. So look at this. This is the point 2,1 right here, right? 2,1. So that's an x value of 2, a y value of 1. So let's see. If we plug in 2 here, we get negative 8/3 plus 11/3 equals 3/3, which is 1. So for an x value of 2 and a y value of 1, oops, not really showing over here. If you plug in 2 for x and y for 1, you'll get a true statement in this equation. So on the homework problems, when they'll say things like, where's what I'm looking for? Here, see, here's one where they say find the slope. So you'll use your y2 minus y1 over x2 minus x1, that whole thing. Find the slope, yeah, use your slope formula. It doesn't make any difference if they're fractions. Just deal with it. You just plug them in the same exact way. The math works the same exact way. When they say here, use the graph to find the slope of the line, well, you figure out your rise and your run. Rise over run is your slope. So in this case, you go what? You go up 1, 2, 3, 4, 5, and you go over 1, 2, 3, 4, 5, 6, 7, 8. So the slope of this line would be 5/8. The rise is 5, the run is 8, so the slope would be 5/8, right? So the slope is 5/8. And I'll submit this. And it says, hey, you got that right. Okay, so that's how you do that kind of problem. Here's what I was looking for. Check whether the point lies on the line having the equation y equals negative 3x plus 4. And they give you the point 210. So you have an x value of 2, a y value of 10. You just plug them in here and see if it makes a true statement. If it's true, then that lies on the line. If it's false, then it does not lie on the line. So that's all you have to do for the problems that are like that. Okay. yeah, and then when you have to draw a line, you just click this and you'll do like from there to there. See how I made the line? And then you can clear all by clicking the clear all. When we get to circles later, you'll do circles, you know. So just play around with it if you're not sure. Don't be afraid to like play around with the graph and make it work. If it marks you wrong on something, you can always just try it again. Okay, so that's how that first section of homework will go. Hopefully most of you are well through that at this point. So then we've got 2 circles and other equations. Let's see. Man, time is flying through here. Let's see. I want to make sure I get through some important stuff. Okay, so let's talk quickly about circles. So when they ask you, you'll have a few problems where they ask you about the midpoint. Basically, you take the average of the x values, and then you take the average of the y values, and that gives you the midpoint. So just add your x values together, divide by 2, then add your y values together, divide by 2. That's your x and y for your midpoint. For the distance formula is where you subtract the values, square them, add those values together, and take the square root. So that's in the ebook, right? So you can easily find that in there. Plus the videos will walk you through. That stuff's pretty straightforward. Here's one where I want to kind of look at a problem like this because this gets a little bit more in depth. I do have a worked out example in the homework for circles. So where I walk you through exactly how to do that. So actually, I think I'm going to skip circles right now because this example that I do in this video right here pretty much sums up how to do those kinds of problems. You're going to use completing the square and you're going to get it in the right form. So just real quickly, what I want to show you is the basics for circles. We have x minus h squared plus y minus k squared equals r squared. Well, let's just leave this now as okay, we'll write it as r squared. Let's do all of these. So what happens is, notice this is your formula for a circle. X minus h squared plus y minus k squared equals r squared. And here's the thing, as we change these values, see what happens is I change the h, it's changing my graph horizontally. We're going to talk about transformations in a few minutes, and you'll see that these relationships hold. Okay, so I put that somewhere. Now as I change the k value, it moves up and down. And look what happens as I change the r value. Oops, if I can get it right there. As I change the r value, it changes the size of the circle. Okay. So basically what we get here is where the h and the k, they give you the center of the circle. So whatever, if you get your circle in this formula, whatever the h is, that's the x value of your center. The k value, that's the y value of your center. And if you take the square root of this number over here, that gives you the radius. Okay, so let me give you an example of what this looks like. Let's take, for example, x minus 3. And in fact, I'm going to mute it so we can't even see it, and then you'll kind of understand, hopefully, how I'm making these predictions about the problem. So I'm just making this problem up at the moment. Okay, so we see the equation that I'm talking about here is, let's see, hopefully it lets me move this up a little. You can see, so the equation is x minus 3 squared plus y minus 5 squared equals 16. So the way our formula works is this is the x value of our center, this is the y value of our center, and this is the square of the radius. So what that tells me is we haven't even seen what this circle looks like, and I just made it up right now, but I can tell you the center of this circle is going to be at 3, 5. 3, 5 will be the coordinates for the center of the circle, and the radius will be 4. So let's take a look. Am I right? Okay, so the center I predicted would be at 3, 5. And sure enough, there it is, right in the center. Oops, it's a little bit off screen there. Let's move it over. So it's at 3, 5. And the radius is 4. Let's see. 1, 2, 3, 4. Yep, the radius is 4. So from the if you learn this formula for a circle, you can pretty easily identify where the center and the radius is. And if you understand the center and radius of the circle, you understand a lot about that circle. So it's very helpful. Okay. One thing you have to be a little careful of is, what if this was a, let's move it to this one over here. See how it says x minus 3? What if I made that a plus? Oh, notice how it moved my circle? Because the way we interpret these, it should always be x minus something. So you want to interpret it when you see x plus 3 in your brain, you have to go, oh, that's x minus negative 3. X plus 3 is the same as x minus negative 3 because our formula writes it as x minus a number, y minus a number. So that means that in this case, our center is now at negative 3, 5 and has a radius of 4. Okay, so just be careful about that. I see some students get kind of mixed up on that part. Okay. And then on the homework problems, you're going to see some more in-depth problems like this where they say find the center and radius for the circle. Well, if you look at this isn't in that form that I just showed you, right? So what do you have to do? You have to do completing the square. So they have a video for how to do it. They have a written example and the ebook, but also I have an example as well where I go through a problem just like that and I work you through each step on how to do completing the square for that circle so that you can immediately identify the center and the radius and graph the thing and all that kind of good stuff, okay? And then I threw in another one here by a chemistry tutor where he basically does the same thing, okay? So you should be able to get through those by watching those videos. Okay, functions. Let's come back to functions in a little bit. I think with functions is one of those things where I could talk for the rest of class about functions, but I think it's good for you to watch those videos, let them sink in, see how the problems work, and then it's one of those things where rather than watching me do it for 30 minutes, it's kind of better for you to work through some of these problems and it'll start to make more sense to you. Okay. Let's jump to transformations for a moment so I can talk about that a little bit. So on here I have, in Canvas, I've got a section on transformations. Where did it go? It was here a moment ago. Oh, looks like I accidentally have transformations up here, right? Transformations is chapter 2. Yeah. Sorry, I had to redo all of the Canvas, so a couple things are still in the not optimal places. So let's move that down to there maybe. Chapter 2, functions and graphs. So what are transformations? Well, I've got a video for you where I explain transformations, and then you'll see I don't do this a ton. Like, this is a worksheet. The worksheet is not an assignment. You don't have to do it, but generally what I have is students come back and say that worksheet was really helpful. Working through that really helped me understand transformations, and understanding transformations is going to make understanding a lot of things in this class way easier, because once you can think in terms of transformations, a lot of problems won't seem quite as complicated as they look at first. So I have a worksheet here for you. And the thing is, if you were doing this by hand, it would be a huge pain. But if you're using Desmos, you can work through this whole thing in like 20 minutes, and then you'll really understand what's going on. So there's a few things that get covered here: domain, range, families of functions, and transformations. Those are 4 big topics from this chapter, all of which you'll work through on here. So the way you're going to do that is, if you choose to do this, which is a pretty good idea, you'd print this out, and then you would go over to Desmos, which is what I've been showing you here. And you can come up with the graphs and the tables very, very quickly. So notice how easy it's been for me to type stuff in here, and Desmos immediately graphs the thing for me. Let's move this over slightly. So for instance, we have the different families of graphs. So if you wanted to graph something, you'd just go, y equals x, use the caret. That's shift 6 for the exponent, and then you've graphed that. Notice if you see down at the bottom, there's a little keyboard. Let me bring this up here. See, there's a little keyboard. If you click that, it's got like, here's how you do squares, and here's how you do the square roots, and here's how you do the different symbols that you may not know how to do directly from the keyboard. And also you can come over here on the right, and if you click functions, it takes you to, are they only trig functions? Oh, yep, those are not functions we'll use for this class. I was thinking they had some for this class, but like absolute value, but it looks like absolute value is over here. Forgot that. So you can use some of that. So, but what I want to show you is the following behavior. Let's get rid of that. The nice thing, so transformations is about how we modify graphs in order to get new graphs. So basically what you have for your families of graphs is you have a representative. So there's lots of quadratics, that's second degree polynomials, but they all have the same basic shape. We call this a parabola, this kind of U-looking shape here. It's called a parabola. Every quadratic is going to give you a parabola of some type. Now those parabolas might be wider, they might be narrow, they might be flipped upside down. There's lots of things we can do to that, but they all belong to this family of quadratics. And when we move them around, the thing is when we modify something that's, say, a parabola, second degree polynomial, those modifications work the same way as if we're trying to modify an absolute value graph. So that's nice. That means once you learn your transformations, they work that way for every graph, not just the particular one that you're looking at. It works that way for all of them. So you learn it once, but you get to use it in many, many different settings. So let me show you what I mean. Let's take, for example, we've got a x minus h squared plus k. And so I've got my sliders here. It asks, do you want to add these as sliders? Yes, I do. So you would do the same thing I just did. And then look what happens when I do that. What happens when I just change the h value? Oh, it moves it sideways. Does that seem familiar? Yeah, because we just did that with circles, right? So remember, the same way that it worked with circles, this value is working for parabolas. So that is the value that's in here with your x, that's going to be a horizontal transformation. In fact, we call them, when the shape stays the same and we just move them either up or down or left or right, we call that a translation. But it's a type of transformation. So you can guess what's going to happen with the k. Oh, it goes up and down. So between h and k, you can move this to any part of the graph that you want. You can move it anywhere you want. Okay, well, what does a do? Well, it looks like when I modify a, it's making the thing skinnier. When I go the other way, oh, it's making it wider. Oh, now it's flipping upside down and a is negative. Oh, so we can predict, oh, when a is negative, it flips the graph upside down. And that works the same way for all graphs. So let's take this and copy it, and then I'll add one in here. That is an absolute value. So I've got an absolute value graph. Let's get rid of this red one for a minute. And notice that these parameters, when I change them, have the same effect as they did with the parabola. So when I change h, it's moving it horizontally. When I move k, it's moving it, oops, why does it keep putting this here? Okay, that was weird. There was some kind of glitch going on where it kept putting another absolute value bar in there for me. I don't know why it was doing that. Anyways, so see how now when I adjust the k, I'm getting the vertical translation just like we got for the squaring function and the circle. So as I change k, it's changing the vertical. So by changing h and k here, I can figure out how things are going to change horizontally, how they're going to change vertically, and likewise, if I go up here and change the a, oh, look, it's getting skinnier again. Now it's getting wider. Oh, now it flips upside down. So the transformations, once you learn them and you learn how they fit in your formula, they work exactly the same way. So let me give you an example of, just so I can sort of show you that we can predict how this is going to work. If we go y equals the square root of x minus h plus k, and I'm going to put an a here. So see how the h is always the part that's next to the x. The k is sort of out there by itself, and then the a is right in front. So I can predict if I change h, that's going to make the graph go left and right. Yep, sure enough, that's what it's doing. When I change k, it's going to go up and down. Yep. When I change a, it's going to change the shape of this thing from more to less severe, and at some point, it flips upside down. So once you learn those transformations and get comfortable with them, you're good to go. Great way to learn it. Print off this transformations worksheet, work through it, and I mean, the worksheet, if you're doing it by hand, would take forever. But if you're doing it in Desmos, it doesn't take very long in order to go through and do. Let me show you how to get a table. So if you click up here and do plus, it'll say, what do you want to add? You can add a table, and see how this looks kind of like your the table that you have in that worksheet. So if we make this, if I modify this to be x sub 1, you do that with a underscore, so x sub 1, and I want to make this squared, then notice what happens when I put a number in here. It squares it for me. What if I put -3? It squares it for me. 0 squares it for me. -1, it squares it for me. So you don't have to sit there and push all these buttons on your calculator to get it to type out, to fill in the table that's in here. You could just put this in in Desmos and then have it calculate those values for you. Okay. Let's see. I thought I saw a message, but no, I did not. Okay. Must have been just a glare. Okay, so that's how your transformations work. One thing you're also going to have to look at is the domain and range, and I know some students get confused about this. So let's talk domain and range. For a function, the domain is all the x values that you can put into the function, and the y values is all the values that you can get out. So the domain, the input, is the x values. The output, the y values, that's called the range. So if we look at something like this, look at your points and ask yourself, what kind of points do the x values, what kind of values can we use as our x values? So it looks like there's only positive values and 0, right? Notice there's no negative x values down here for our graph. So then we would say the domain goes from 0 to infinity. And what about the, so the x values, the inputs go from -infinity to infinity because we have, it's everything along the x-axis. If we go up far enough, we'll see parts of the graph. So the domain would be -infinity to positive infinity. All x values can be put into this graph, but the y values, there's nothing down here that's negative, so the y values, the range, are only the non-negative values. I was reading chat at the same time. So someone's saying, sorry, I missed where you go to use the slope graph. I'm not sure completely what that means. You can either follow up with me after class or maybe reword that, and I can try to understand what that means. So we have here, so you can actually look at this by just looking and going, well, the only parts of the, like for the x-axis, every single point you pick on the x-axis is going to have a point on this graph. You just have to go up high enough. But for the y values, there's no y's down here, so you can see it's only the positive values. and 0, right? And also watch the videos that are associated to those particular problems. Okay, let's see, where are we? Functions, graphs of functions, analyzing the graph, rate of change, and difference quotient. Right, so let's look at some of these. Okay, so even, odd, or neither. So there are very special graphs that are called even or odd, and most graphs are neither. Most graphs are not even and they are not odd. So what does this mean? Even, basically, like this graph that we're looking at right here, this is even. The reason we say that is basically what an even graph means is that it's symmetric with respect to the y-axis. So say we printed this out and I folded the piece of paper along the y-axis, these two curves would line up on top of each other, right? That means they're symmetric with respect to the y-axis. So we would call that function even. Don't get too hung up on the words even or odd. Sometimes people get too concerned about the numbers over here being even or odd, but that's not always the case. There are always rules that break that, or there are examples that break that rule. So don't worry about the numbers over here being even. Just think of when we say even, that means we're symmetric with respect to the y-axis. If you printed this out and folded it on the y-axis, would the two sites match up? Not 100% sure if I understand the question in chat, but yes, the website that I'm using is called Desmos. It's DESMOS.com. It's totally free. You don't even have to sign up for an account. You can just start, if you click the main page, you can start using the graphs right away. And you can kind of follow along with what I'm doing to get the graphs in there. And if you're ever trying to do something on Desmos and you're not sure, just Google it. Like some students get confused when they're doing like the cube root. You can just say, how do I put the cube root into Desmos? And someone's gonna either have a video or an explanation on how to do that. Okay, great. Glad we got your question answered. So so this is an even function. Let's look at an example of an odd function. This is an odd function. Now the symmetry is a little bit different. It has different types of symmetry. In mathematics, there's tons of different types of symmetry that you can have. So you could argue that this has rotational symmetry. Imagine if we took this graph and we just rotated it 180 degrees, it would line up on itself again, right? So it's got a rotational symmetry. You also can say that it's symmetric with respect to the point, the origin. Now it's kind of weird because when we talked about even functions, we talked about with symmetry with respect to a line. Now we're talking about symmetry with respect to a point. If you take, say, this point here and you direct it right through the origin, and you end up with this point over here, yeah, those are symmetric with each other, right? They line up on each other. Like I say, you could also think of it as rotating it 180 degrees. Oh, actually, we haven't done roll. That's a great question. I should do roll in just a second. So when you're doing these problems that say, is this even, odd, or neither? Like this one's going to be even, right? Because if we fold it along the y-axis, this side will line up on this side. So that would be even. Yep. See? So it's an even function. Then we go to this one. This one's going to be neither. This looks kind of like that odd graph that we did, but it's not symmetric with respect to the origin. It's kind of shifted off over to the side. So this one's going to be neither. Right? It's not either one. And then, so you just have to keep going through and looking at these for the different types of symmetry. Right. Okay, with that said, that's a great point. Let me take roll. Okay, let's see who we got in Zoom first. right, looks like we have a few less people showing up today. So, I may have missed people. So, let me know if I call your name and you're here. Just make sure that you make yourself known. So, I'm missing Flavio A, Cynthia C, Raymond C, Daniel D T, Veda F, Sergio G, Laura G, Chrisley K. I think this person dropped actually. Lily L, I think is gone. Raymond L. Zolly T. I don't know if I'm saying that right with an X. Zolly T. And I think this person dropped as well. Charles V. I know like a few more people dropped. Okay, what do we got? Cynthia Cervantes. Okay, Cynthia, I got you. Oh, Chrisley. Okay, let's see. Got you. Okay, I think we got everybody then. So, like I say, I think about 3 more people dropped in the last few days. So just make sure you're showing up. I know it's hard, and as time goes on, people get tired and things start to pile up. But really, there's a pretty clear connection between attendance and pass rates, right? There's a few things that are just very strong predictors. Are you getting your homework done? Are you showing up to class? Those are 2 very strong predictors of if someone is going to pass the class or not. Okay, so with that said, where are we? We talked about those things. Okay, let's back out of that. Okay, so we talked about, let's see, we have about 15 minutes to talk about a few things here. So we've got algebra and composition with functions. So this is the main thing here that's new is what we call composition. So you'll do other, like they'll talk about the algebra of functions. Let's see, was that this one? No, we want to go. Oh yeah, we do want that. Rate of change and difference quotient. So let's talk about that. So your rate of change is just your slope. So whenever you see a problem that talks about rate of change, just calculate the slopes between the points that they're identifying. So that one's not too bad. Here's a piecewise function. Just sort of follow the directions here. So they say find the average rate of change on the interval from -4 to 4. What you would do is you'd go to -4, 0, that's 1 point, and +4, -3. Those are the 2 points you care about. Now just plug those into the slope formula, and you'll be good to go. Okay? That's all. It sounds fancy. That's all you got to do. Okay? So just do that. Just take the 2 points that they talk about on the ends of the interval, -4 and 4. Use those as your x values. Get the points. Plug them into the slope. Right? And there's a video here where they're going to do exactly that. They're going to find those 2 points, throw the slope formula at it. So that one's not too bad. Then we've got even or odd. Average rate of change. So in this case, they ask about the average rate of change. What you're going to do is take these 2 x values. So you take this x value of -2, you plug it in here, get a y value. Take this x value, plug it in here, get a y value. You now have 2 points. Throw it into the slope formula. That's all they want you to do here, right? Oh, it said difference quotient in the problem, but none of these homework problems are on the difference quotient. So never mind for now. Here we go. Okay, so then we want to talk about the algebra of functions. So a lot of these are going to be a little straightforward, the algebra parts, where they say like, basically you take these two functions and here they're telling you to divide them. So just, you know, create where you have f on top, g on bottom. And then they have one where they're saying add them together. Just take these two functions and add them together. Those basic addition, subtraction, multiplication, and division, those are pretty straightforward. But then we get into something called composition, which is new for people. Like here when they say, this isn't even composition yet, but they say g of h of 1. What that means is take g, multiply it by h, and then once you've figured that out, plug -1 into that function. Whatever you get, plug -1 into it and see what you get. Right, is all they're saying. Let's go ahead and open the ebook and take a look at that. Wow, this is way too big. Let's make that a little smaller. Go one more bigger. Okay, so those I think are pretty straightforward. Follow the examples in the book, follow the videos associated with the problems, and you should be good to go. What I want to talk about is composition. Here we go. So the composition of functions, f and g, is a function that is denoted f circle g and is denoted as f circle g of x equals f of g of x. I like the notation on the right myself. I think it's just a little more clear. This is an older notation that's a little bit going out of fashion, but you still need to know what it looks like because you're going to have teachers who use it. So, but this is helpful because for this f of g of x, you just kind of think of it as working from the inside out. Let me make that a little bigger. So that means you're taking x, you're putting it into the function g, whatever comes out, you put it into the function f. So there's usually a picture that they put in these. We're not going to get a good picture here. Nope. Okay, most books give us a good picture. So composition works a little bit differently in that the way it works is that you have two functions, but you're not really dealing with them at the same time. You're dealing with one, and then you deal with the other. Like when we add two functions together, we're dealing with both at the same time. We just take the two functions, we add them together, see what you get. For composition, this says you're going to take x, you're going to put it into the function g, and whatever comes out of that function is now going to go into the function f. In other words, you have to do it in a specific order or it won't make sense. But basically all you're doing is feeding the output from one function into the input of another function. So let's take a look at exactly how they're going to ask you about composition. So here they're having you evaluate the composition and then evaluate it at a specific x value. Okay. There's the difference quotient. They have it. They cover the difference quotient in this section, but they have it labeled in a different one, so it doesn't quite match up. So let's take a look here at both of those topics with just a few minutes left. I have a difference quotient video somewhere. I will make sure to link that into Canvas. Somehow it's not in there. I overlooked posting it, but I will post that to get that in there for you because I don't think we're going to have time to do the difference quotient. But somewhere in here there's a difference quotient video. So I'll look for that. Yeah. Okay, good. So there's a question in chat and it looks like someone else answered it. So that's great. So then I can, that's helpful. So then I can keep working on here. So for composition, let's take a look at how composition works. Let's go down to the next one and say if f of x equals x squared plus 1, and g of x is equal to 2x minus 3. Find g of f of x. Now, one thing that's important to know is that g of f of x and f of g of x are generally not going to be the same thing. So you have to make sure you get the order, get things in the correct order. So that's why it's important to kind of follow them carefully. That's not what I wanted. Okay, so we've got, let me move this over. We've got f of x, we've got g of x, and we want to find g of f of x. So basically, if you read this, if you think about function notation, this is telling us to feed f of x into g of x. Okay, so what's that going to look like? Let's take a look. So we're going to be seeing g of f of x. Well, we know what f of x is. It's given in the problem. So this really means take g and plug into it x squared plus 1. Right? Do you see what I've done? All I've done is taken the f of x here, and I replaced it with what it says f of x is equal to. It says f of x is equal to x squared plus 1. So I took the f of x and I plugged it in over here to this part. Right? Okay. Well, what does g say to do? G says for any function, we're going to double it and subtract 3. So basically, we replace the x with the x squared plus 1. So this will become 2 times x squared plus 1 minus 3. Right? And then what you're going to do is you're just going to simplify it from here. So this will become what? This will become, let's go to a different line. This is going to become 2x squared plus 2 minus 3. Right? Just distributing that 2. Which is going to be 2x squared minus 1. So g of f of x is the same as 2x squared minus 1. Okay. Now, if we tried to figure out f of g of x, we would get something a little bit different. Right? It might be similar, but a little bit different. Okay, so that's how you'll do those composition of functions. So do the composition, get your function that they want, and then sometimes they're just going to have you plug an x value into it, so just do that. Sometimes they're going to have you do something different, something a little bit fancier with that thing. And then the difference quotient, I'll find that video for difference quotient. I think it's not in here, so I will get that posted. I'll find it. Like I say, I'm still finding exactly the right spot for things. I've definitely got a difference quotient function video floating around, so I'll put it in here. Okay, so I'll post that here, I don't know, in the next few minutes. So kind of looks like we're out of time except for maybe a wrap up. We have about 2 minutes left. So things that you want to do. Make sure as of today you have your testing center appointment all taken care of. You're not going to be able to take the test after next week. It just won't happen. So because we have to move ahead. So make sure you get it taken. It's not fair to the people who take it on time. If I let other people take it late, then the people who took it on time are like, well, why didn't I get extra time, right? So we have to have those dates set. So make sure you get that taken care of. Don't procrastinate on setting up your appointment. Make sure you get your Scantron. That is form 825E. So it's 825-E, but I think it's the only one called 825E. So it has 25 problems on the front. You probably use these in high school from time to time. The bookstore, I think it's like 33 or 38 cents or something like that. I bought one. As you can see, I have a couple of them. There's a question here. The Scantron will not be used for the final. On the final exam, you will have, it'll be a written test. You're going to write out the test. You're going to go ahead and write them out, all your work, and you'll get partial credit and all that kind of stuff. But for the first exam, it is a Scantron. Okay? So you only need one. You'll only have to buy one, and you're good for the whole semester, at least for this class. Okay? So get your appointment, get your Scantron, make sure you're all set to go. Work on that practice test, and by all means, use those resources. Form study groups in this class. If there are people who want to get together, form your own Zoom meetings, or people who want to get together in person. There's the library has rooms that you can check out, and like a group of people could sit in there, or you could go someplace, get a pizza and some sodas, and just work on your practice tests for a couple hours together, whatever it is you like to do. There's also the tutoring center. You're totally welcome, right? I always have a couple students that are like, oh, I didn't think I could take the practice test to the tutoring center. You should take the practice test to the tutoring center. That tutoring center is there meant to help you. So they will help you work on those problems before you have to be tested on them. And then make sure you're comfortable with things through Chapter 3. Watch the videos on how to do those particular topics. So again, Chapter 3 is not due until late next week, but you want to be working on it ahead of time if you can help it. Okay. Any questions? No? Okay, then as usual, I'm going to shut down the YouTube stream, but I will sit around in Zoom as long as there's people in there asking me questions. I will stick around and help you with whatever it is that you need to know. Okay, thanks everybody. Good work, and I will see you later. Oh, and don't forget, July 4th is a holiday. Anything related to the college will be not operating on July 4th. Okay, so have a good holiday. Stay safe.